let us briefly once go back and let's see what we have discussed in our previous session. So we have started with our different cases. First, we have seen these different cases: case 1, case 2, case 3, case 4, case 5, case 6, up to case 7. 7 cases we have seen. And after that, we have started with something known as event scheduler. So this was a very important concept which we have started: active, inactive, NBA, postponed. This regions we have seen, and what is happening in the active region also we have seen in our previous sessions, right? And we have also seen about the display statement, what is mean by your dollar display statement, how it is going to work, okay? And how dollar display is working with your non-blocking assignments, and how your dollar display is working with your blocking assignments, and how your dollar display is working when you are having a delay, okay? This and all things we have discussed in our previous session. Now let us talk about one more thing, which is your dollar. And one more time we will once see the active region. So in the SV, in the Verilog event scheduler, we will have basically the first region as active region, and next is inactive, followed by NB region, postponed region. First of all, let us see what is happening in the active region. So what we have discussed in the active region. So in the active region, we have basically blocking assignments are executed in the case of your active region, and evaluation of RHS of NBA regions. Only evaluation is happening in the active region, whereas the updation of these values is happening in the uh, NBA region. Okay, that we have seen. And continuous assignments in data flow modeling, we are going to learn about this continuous assignments. And dollar display statement is also been implemented in the active region itself, right? And we have also seen that evaluation of inputs and updation of outputs, right? So these are all the things which we have discussed in our previous session. Now in this particular session, first of all, let us try to understand about our next type of regions, that is our NBA region and postponed region. First of all, before that, we will discuss about some more system tasks, which is my dollar monitor. So basically, this dollar monitor is also used for displaying your content. It is used to display the variable values, display the values or messages onto the console. This is the role of your dollar monitor. Now, sir, we are having dollar display also. Then what is the use of dollar monitor again? So use case of this dollar monitor is very. We have a very good use case of this dollar monitor. Basically, your dollar display is going to execute only once. This dollar display statement will be only executed for once. For example, if you are writing always, or if you are if you are writing always at the rate star, normally you are not going to write the system tasks with your always block, because this dollar display or your dollar monitor, this and all non-synthesizable, this and all non-synthesizable. So if you want to write a code which is synthesizable, then you should not use it within your always block. So normally you are going to use another block which is known as initial block. Basically this is not synthesizable. Okay, so here if you are writing begin, a is equal to 5, dollar display a is equal to percentage d comma a, then what is going to happen? Your value of a is going to become 5. Okay, now let's say if you are writing initial begin, a is equal to 5 hash 1, a is equal to 0, and if you are writing dollar display the value of a, then it is going to display the present value, that is a is equal to 0, it is going to display. Whereas coming to this dollar monitor, this dollar monitor is going to execute whenever there is any change in its argument. Okay, I will write down here: whenever there is any change in the arguments, change in the value of the argument, then this dollar monitor is triggered, then this $monitor system task is going to trigger. That is, it is going to get executed. For example, if we are having $monitor A comma B, then whenever there is any change in the value of A or whenever there is any change in the value of B, this particular $monitor will be executed or it is going to be triggered. That is the role of this $monitor. Whereas your $display, it is going to be executed only for once. Whereas your $monitor, it is going to execute whenever there is any change in the values of your A or B or any arguments which you have provided inside your $monitor. Is it clear? Any doubts or any queries in this? Next. So in which region this $monitor is going to be executed? So in the postponed region, this $monitor is going to be executed. This $monitor is going to be executed in the postponed region. That is, we have this active region, inactive, NBA, and postponed. So in this postponed region, this $monitor is going to be executed. Okay, whereas $display will be executed in the active region. $display will be executed in the active region. Okay, so you need to remember these two important points. Whereas here your $monitor is executed at the postponed region, whereas your $display is getting executed or called at the active region. Okay, now let us see one example and please let me know the answer for this initial begin. Let's say this is my case 1. Again, we are going to consider the cases. Initial begin. Let's say I've declared some reg A. Let's say if my A is equal to 1 and if I am using $monitor, the value of A is percentage %D comma A. Now what will be the value of A that will be printed? Can anyone tell me what will be the value of A that will be printed? I have simply written exactly 1 will be printed. Let us see what is going to be printed. So I'm going to write different cases like in our previous sessions I've written different cases, right? Here also I'm going to write down the same thing. I'm going to use different cases and using these cases let us try to understand them. Okay, so module example, and in this I'm going to declare a reg A, and within an initial block I'm going to use begin A is equal to 1 $monitor, the value of A is percentage %D comma A, end, and end module. This I have written and let me run this. So the value of A is 1. That is what we are getting. Okay. Now let's say if I now let's say if I am using this $monitor. Okay, this is my case 1. Let me write down this as my case 1. Okay. Now let's say if I am using my $monitor before this assignment. Okay, if I am using this $monitor before this assignment, let's see how to write this. Now what do you think, what will be printed, whether the value of A will be printed or what is going to be printed in this particular case? If I'm writing this module example reg A initial begin $monitor, the value of A is percentage %D, A is equal to 1, end module. So what will be the value of A that will be printed in this example? What do you think? Okay, let's see, let me run this. Let me comment the above code and let me run it again. Yes. So the value of A that is getting printed is equal to 1. Why it is happening so? Can anyone tell me? What is the reason? In the dollar display case, when we were discussing and when we were writing the dollar display before the assignment, we were getting the previous value that is displayed. But here, the present value only displaying, but we are writing the monitor statement above the above this assignment. So what may be the reason why it is getting printed? And I will write down the case 2 here. So in the case 2, we are writing dollar monitor above the assignment and blocking I'm using a blocking assignment. Then the result is I'm getting the value A to be printed. I'm getting value of A that is printed to be 1. Okay. Now coming to the reason why it is getting exactly. The coming to the reason why it is getting printed so is dollar monitor is called in the postponed region. Dollar monitor is called in the postponed region, whereas this assignment is happening in the active region. Okay. If you remember the active region, postponed region, active region is present at the first and then after only postponed region is being called. Okay. So dollar monitor is executed after the assignment has completed. Okay. That is why the reason you are getting the value of A to be printed as 1. Is it clear? Any doubts or any queries in this? Exactly. Statements will be executed at active region. Exactly. Correct. Okay. So this was my case 2. This was my case 2. Now let's see my case 3. So coming to my case 3, I'm going to have a module example. Okay, let me copy from here only. Coming to my case 3. Let's say if I'm using this dollar monitor below this statement and I'm using a non-blocking assignment. Now can anyone tell me what is the value that will be printed in this example? Let me run this. What is the value of A that will be printed if I'm using a non-blocking assignment with my dollar monitor? 1. So what is the reason 1 is printed here? The evaluation of RHS is happening at the active region, whereas updation to the LHS is happening during the NBA region. Okay, I will draw here. So let me write down the case 3 first. So coming to my case 3, what I'm doing is I'm writing A non-blocking of 1 and I'm using dollar monitor and I'm using dollar monitor here. Now what is happening? I'm getting the result as A is equal to 1. The result as A is equal to 1. Now what is happening? This is the updation is happening. Updation is happening in the NBA region and this dollar monitor is called in the postponed region. This dollar monitor is called in the postponed region. That is the reason your value is getting printed. Okay, your your NBA region will be present here, and after NBA region, you are going to have your postponed region. Okay, after NBA region only, you are going to have your postponed region. That is the reason your value is getting printed. Okay, is it clear? Any doubts or any queries up to here? Yes. Now let us see one more case. This was my case 3. Let's see the case 4. Coming to my case 4, I'm going to use dollar monitor above this statement. Use dollar monitor above this statement. Yes. Now what will happen? What will be the value that will be printed in this example? Yes. So 1 will be printed. Okay. Let me run this. What is going to be printed? If I'm using dollar monitor above this statement, 1 will be printed. Let me show you. Yes. So the value that is getting printed is value is equal to 1. Okay. So this is how your dollar monitor is going to work and this is your case 3. Okay. Now let's see one more case. This is my case 4. I think someone has unmuted their mic. Yeah. And coming to case 4. In case 4, let's say if I'm using #1 A blocking 0 and $monitor I'm using below this. Now what will be the value of A that will be printed? What will be my result? And I will write it down here. I'm going to write A is equal to 1 blocking assignment, and I'm going to use an inter assignment delay. Okay. And I'm going to write down this $monitor below this statement. Okay. And I'm going to write down this $monitor below this statement. Now, what will be the value that will be printed? At 1 nanosecond, A is equal to 0. Uh, 1 second, I'm writing A is equal to 1. So, what is getting printed? Exactly. So the value of A that will be printed, that will be equal to 1. Exactly. Now this was one case. Now let's say if I'm using uh, intra assignment delay with my, sorry, if I'm using inter assignment delay with non-blocking assignment. So this was my case 4, and case 5 which I'm going to write down is, in the case 5 what I'm writing is A #1 non-blocking 1, and I'm using $monitor. Now what will be printed in this case? What will be my result? I'm using a inter assignment delay with a non-blocking assignment. Now what will be happening? A is equal to 1 only will be printed, because I have told you. So #1, if I am using an inter assignment delay, then it is going to block the compiler. Only after 1 nanosecond only you are going to execute this A is equal to 1. Okay. And then only it will be the updation will be happening in the NBA region. Okay. And your monitor will be printing the updated value in the postponed region. That is the reason. Now let's say if I'm using an intra assignment delay here. Now what will be the value that will be printed? What will be my result? This is my case 6. So in my case 6, what I'm doing is I'm using a non-blocking assignment with an intra assignment delay, and I'm writing $monitor. Now what will be the value that will be printed? What will be my result? Okay, let's check. So I'm getting two values that is getting printed. So initially my value of A that is printing is X. Okay. Since I'm using a non-blocking assignment with an intra-assignment delay, this particular compiler is not going to wait until the updation of this value. Okay. So it is going to implement this $monitor. $monitor is triggered, and it is going to wait for the updation. So when this updation is going to happen? Updation is going to happen at NBA region. Okay, after updation, again the value, since the value of A is getting changed from X to 1, there is a change in the argument. So that's why this $monitor is called again, and it is executing this statement, and it is printing the value of A is equal to 1. In this example, if you use $display here, if you use $display, then you will get only one display statement as A is equal to 1. You can see here, let me show you. So you are only getting A is equal to unknown because you are using a non-blocking assignment. So these two statements are going to be executed, and the value is not yet updated in the active region. So display statement, it is only displaying unknown value. But if you are using $monitor, what is happening? If you are using $monitor, then it is uh, started its execution at time t is equal to 0, and at time t is equal to 1, again your updation A value is getting updated. So that's why this monitor is triggered, and it is displaying the value of your A. So this is the reason you are getting 2 times printed if you are using a $monitor. Is it clear? Yeah. So this is a very important observation. You need to be very careful in this particular observation. Okay. Yes. So this was about your $monitor and $display. Okay. Now there is one more thing in the postponed region, that is nothing but your strobe. So this dollar strobe is also executed in the postponed region. Your dollar display and dollar strobe are functionalities are same only. They are going to execute only for once. But the main difference between your dollar display and dollar strobe is dollar display is going to be executed at in the active region, whereas your dollar strobe is going to be executed in the postponed region. That is the main difference between your dollar display and dollar strobe. Okay. For example, if you are using your dollar display, let me erase this. If you are using your dollar display, the value of a is percentage d comma a, and if you are using a non-blocking assignment, what will be the value that will be printed? Displaying from display statement, display task, and let me copy this statement and I will write down strobe, dollar strobe, the value of a is displaying from strobe task. So let's see the difference between these two statements, what is happening. Yeah. So the value of A is unknown, displaying from display task. Whenever we are using display task for displaying this non-blocking assignment, we are getting unknown. But the strobe value, we can see the value of A that is printing 1, that is displaying from strobe task. If you are using a strobe, then this strobe will be displayed. That is, the strobe will be executed in the postponed region. Okay. Whereas your display statement is executed in the active region. Okay. And the updation of your NBA is going to happen in the NBA region. That is the reason you are getting the value that is being printed using the strobe task. Okay. So these are your different system tasks. Both will be executed at 0 nanosecond. Which one? These two statements are you asking about? Yes, exactly. Okay. Is it clear? So that was about your event scheduler and everything. So let me recap one more time. You are going to have active region, inactive, NBA, and postpone. So order is from active to inactive, inactive to NBA, NBA to postpone, and you can also go back to active, and you can also go back to inactive, and from here also you can go back to active. Okay. So how we are going back and what are the cases we are going back, that and all we are going to discuss later, because we need to start coding. We need to have some coding also. After that, still in some advanced concepts, I will explain you when we are going to active and what are the things I'm going to explain. Okay. And for every time slot and from this postpone, you will go to next time slot, and from previous time slot, you are going to previous time slot, you are basically coming to this present time slot. Okay. So this is how you are going to use this system tasks according to your event schedule. Okay. Are they clear? Any doubts or any queries in this? Now, so with this, we have completed our event scheduler. Now, let us start with the coding in this behavioral modeling. Let us first of all start with a basic half adder. Okay. Let us see how to code this half adder in behavioral modeling. Okay. So how to do that? First of all, we already know we will declare a module which is known as half underscore adder, and the inputs for this is A, B, C. A, B, and outputs are my sum and carry are my inputs and outputs. Now here I am going to simply write down a always block, always at the rate A comma B. So if there is any input change, then only this always block will be triggered. Begin sum is equal to A XOR with B, and carry is equal to A and with B. Whether it is a bitwise operator or logical operator, can anyone tell me whether this is a bitwise operator or logical operator? Exactly, bitwise operator. Okay, that's it. This is a code how you're going to write down in the behavioral modeling. And you should be careful. If you want your code to be synthesized, you are not supposed to use initial block, and you are not supposed to use hash operator. These operators are not uh, used if you want your code to be synthesized. That is, if you want your code to be run on the hardware. Okay, you're not supposed to use them. Okay, so this is how you're going to write down your basic half adder. And before going to discuss about Testbench, I wanted to explain about this another procedural block, which is initial block. Now, as the name suggests, this initial block is going to run only for once. It is going to execute only once. Okay, and it is going to start its execution. It is going to start at time t is equal to 0, and it is going to end whenever all the assignments in this initial block are completed. Okay, for example, this initial block rules are all same as your always block only. The main difference is initial block is non-synthesizable. This initial block is non-synthesizable. This cannot be used when you want your code to be implemented on the hardware. Okay, and it is only used for test bench development. This is only used for your test bench development. Okay. Yes. So this was about your initial block. And also LHS cannot be of wire data type. Same as your wire or net. Same as your always block. Initial block also LHS cannot be of wire or net data type. Okay. For example, if you are having initial block, if you are going to have multiple statements written inside this initial block, you should use begin block. If you are going to have multiple statements which have written inside your initial block. And this initial block is going to start its execution at time t is equal to 0, and it is going to end whenever every line of the code has been completed its execution. Okay. Now, and if we have multiple initial blocks like this, initial, beginning, initial, beginning, like this. If we have multiple lines of codes written, then this two initial blocks will be running concurrently. That is, they are going to run parallelly. Okay. So these two initial blocks are going to run concurrently. Okay. So these two initial blocks are going to start their execution at time t is equal to 0, and they are going to run parallelly. So this was about your initial block. These rules you should be careful and you should follow accordingly. Yes. So as we have written our design for a half adder, let us try to understand how to write a test bench. So first of all, before going to write a test bench, let us try to understand what do you mean by a test bench. We need to understand what do you mean by test bench. Let's say this is our design. This is our simple half adder. For this half adder, we have two inputs A and B and two outputs sum and carry. Now, basically this test bench is a module which is going to provide your design a set of inputs and going to collect your outputs. Okay. So it is a wrapper. You can think of a wrapper which is going to have this design inside it. This is your test bench. So this test bench is going to provide the design, the corresponding inputs, and it is going to collect your corresponding outputs. Testbench is also a module. This is also a module which is written inside your module. And this module inside your testbench, your design is going to be instantiated. And whatever the design inputs we are going to have, that particular inputs your testbench is going to give, and the outputs are collected by this testbench. Okay. Now, for writing any test bench, basically we have some specific set of steps. Okay, so I basically recommend this particular steps if you are a very beginner when you are writing, if you are a very beginner in test bench writing. Okay, so for every combinational circuit we will have this same steps. Okay, and for all the sequential circuits we will have the same number of steps. Okay, let us see what are the steps we are going to follow for combinational and what are the steps we are going to follow for the sequential. Okay, so for combinational circuits we are going to follow, let me write down test bench for combinational circuits. For all the combinational circuits, we are going to follow the same steps, and for all the sequential circuits, we are going to follow a specific set of steps. Now, what is step 1? For combinational circuits, if you are writing a test bench, these are the steps. Now, step 1. Step 1 is we need to connect the inputs and outputs. For that, we need to declare some variables inside our module. Okay, that is step 1. Declare variables for connecting input and output of the design. So, variables which are connected to input should be declared as which data type? Can anyone tell me? So variables which are connected to the input should be declared as which variables? Let's say suppose if you are declaring a underscore tb and b underscore tb, what should be the data type of this a underscore tb and b underscore tb? Can anyone tell me this? So it should be only rich or it can be wire also. No, it can be wire also. Okay. So the variables which we are connecting to this inputs, this can be of rich or this can be of wire. In the port connection rules, we have discussed it. So it can be of rich or it can be of net. Mostly we are going to use rich because this inputs we are going to drive or we are going to supply using the initial block. So that's why we are going to have declare them as rich, but you can also declare them as net also. If you are declaring them as net, you cannot use it in initial block. Okay, that is the reason. And coming to step 2, what is your step 2? Step 2 is instantiating your design. Instantiation of design in Testbench. Instantiation of your design in the Testbench. Okay, you can follow connection by name or connection by order. Anything you can follow. And coming to step 3. Step 3 is initialization of your inputs. Initialization of inputs. We should initialize our inputs. Okay. And step 4 is driving our inputs. Driving the inputs, that means I'm basically providing the values to the inputs. Like for say suppose a is equal to 0, a is equal to 1, b is equal to 0, b is equal to 1. That is nothing but driving the inputs and collecting the outputs. You can use dollar display, dollar monitor, you can use for collecting the outputs. Okay, these 4 steps are used for every combinational design. Okay, for any combinational design you take Testbench. It's a very simple thing, you can write it down. Testbench, you're basically going to provide the set of inputs to your design and you're going to collect the corresponding outputs and you're going to verify them whether they are correct or not. That's it, you are going to do this simple task. Okay, let us try to write down the Testbench for our design. So in EDA, if you are writing, so this is my 1 minute. Let me copy this. This is my design side. The right hand side is my design, and the left hand side I'm going to write down my test bench. How to write my test bench? Simply, first of all, write any name. Let me write down it as test bench. Okay. Now, what is step 1? Step 1 is to declare the variables for connecting input and output of the design. How to connect it? Reg a underscore tb, comma b underscore tb. I'm taking different names to avoid the confusion. That's it. And for collecting your outputs, you are going to declare them as wire. Okay. Why? What is the reason? This we have already discussed in our port connection rules. If you haven't watched them, please I recommend you to once rewatch that. Okay. Now this was our step 1. Okay, let me write down this is my step 1. Now what is my step 2? My step 2 is instantiating my design. How to instantiate my design? Design name. What is my design name? Half underscore adder. What I should provide some instance name. Instance name is, let's say, DUT. DUT is nothing but design under test. You can give any instance name. And I'm following connection by order. This is my connection by order in which I'm following sum underscore TB and carry underscore TB is my instantiation step. Next is my step 3. What is my step 3? Step 3 is initializing your inputs. How to initialize your inputs? Using initial block, you are going to initialize them. Initial begin A underscore TB, B underscore TB is equal to 0. I'm using a concatenation operator for initializing the things. Okay. You can write simply 0, or you can write 2-tick binary 0 0. Okay. This is my concatenation step which I'm writing. Next, after initialization, you are going to drive the values. That is my step 4. What is driving? Driving is nothing but providing my values to the design. How to provide the values? Simply within an initial block, initial begin. What is the set of values you are going to provide? A underscore TB is equal to 0, comma, B underscore TB is equal to 1. Okay. And you can use the dollar display statement here only. Dollar display, the value of sum is percentage D and carry is percentage D, comma sum, comma carry. Or you can use dollar monitor also. Okay. Only for once you can use dollar monitor and it will display for 4 times. Okay. And I'm ending this end module. I'm not writing all the 4 possible combinations. I'm only writing the one possible combination. Yes. So we are getting the value of your sum is equal to 1 and carry is equal to 0. Is it clear? So this is how we are going to write down our test bench and how to see your waveforms and how to verify it with the waveforms that we will discuss in our next session using the Vivado tool. Okay. So using the Vivado tool, we will discuss how to view the waveforms and how to check our outputs in the waveforms. That and all we will discuss. Yes. So that's about this particular session. If you have any doubts or any queries, you can stay and discuss with me, or else you can leave the session. Okay. Thank you.